we are going to finish our study guide today. The last thing that we left off with yesterday in class was a page that looked like what you see in front of you on parallel and perpendicular lines. Let's remember that when we write equations for parallel and perpendicular lines, or if we're comparing parallel and perpendicular lines, what we're really looking for is the slope. In parallel lines, we know that the slopes are going to be the same. In perpendicular lines, we know that the slopes are going to be the negative reciprocal of each other. What we're going to do here is we're going to talk about writing an equation when we're given a particular set of situations. So, for example, the first question here wants us to write an equation for a line that is parallel to y equals 3 halves x plus 2 and passes through negative 2, 1. The first thing that we need to do here is identify, and there's no math involved in this, it's just understanding slope. Identify the slope. Then we're going to write an equation in point-slope form. And from there, we're going to transform the equation into slope-intercept form. So for the first example, an equation for a line parallel to y equals 3 halves x plus 2, we know that the slope of our parallel line is going to be the same, 3 halves. We know that it's going to pass through the point negative 2, 1, and you've heard me say it 100 times. If you know the point and you know the slope, you can write an equation in point-slope form. So from here, we would have y minus 1 is equal to 3 halves times the quantity of x plus 2. So that takes care of our point-slope form. Now all we need to do is transform it. From here, we would have y minus 1 is equal to 3 halves x plus, I know you love when that happens, plus 3. We're going to isolate that 1 and look at what we're left with. Y is equal to 3 halves x plus 4. All right, we'll follow the same steps for the next problem. Now we're looking for a line that's perpendicular to y equals 3 halves x plus 2, passing through the same point, negative 2, 1. Our slope here, let's remember what we know about a perpendicular line, should be negative 2/3. Remember, it's a negative reciprocal, and we're passing through the point, negative 2, 1. I can again write an equation in point-slope form. Y minus 1 equals negative 2/3 times the quantity of x plus 2. There's my equation in point-slope form. Now I'm ready to transform it. Y minus 1 is equal to negative 2/3 x plus negative 4/3. Now you know that on the next line, I'm going to change that just to make the adding and subtracting in the last step a little bit easier. I'm going to change it to negative 1 1/3, and now I'm going to add 1 to each side, and from here, I'm left with y equals negative 2/3 x plus negative 1/3. All right, so our steps for writing equations of this kind, we first have to identify the slope. We'll know a point in the slope so we can write an equation in point-slope form, and from here we transform. Now on your review sheet last night, you had a couple of sort of interesting situations with horizontal and vertical lines, and that's what we're going to talk about next. So suppose we have a situation where the line is parallel to y equals 2 and passes through the point negative 2, 3. First of all, I'm thinking to myself, I'm not even thinking math, I'm thinking more, what do I know about a line that looks like y equals 2? Well, I see y equals 2 and I'm thinking, I know that that is a horizontal line and that a horizontal line has a slope of 0. So I can do this one of two ways. There's a really easy way to do it and a really, well, not a really hard way of doing it, but a more mathematical way of doing it. If we know, I'll give you the easy way first. If we know, for example, that we're looking at a line that's horizontal because it's parallel to a horizontal line, and it passes through an x of negative 2 and a y of 3, I know that my equation is going to look like this. Y equals length. All I have to do is think to myself, well, I know that x is -2 and y is 3. So what does y equal? Y equals 3. If you want to see the more mathematical way of showing this, I will show you that too. Point slope form. We have a slope of 0 and a point of -2, 3. I know the point, I know the slope. Watch what happens. Y minus 3 is equal to 0 times the quantity of x plus 2. Y minus 3 is equal to 0 times anything is 0. I add 3 to both sides, and mathematically look at what happens. I end up with the same equation. To me, it's easier to think about this way of doing it because I'm thinking I know a horizontal line is going to be y equals some number. Y equals some number. All I have to do is look back at my point, and I'm thinking x is -2, y is 3, and I plug that 3 in for the y. Okay? For a perpendicular line, I can do the same kind of thing. I know that an equation y equals 2, that a line like this, obviously we know is horizontal, has a slope of 0. What's going to be perpendicular to a horizontal line? We have to make an equation for a vertical line. How does a vertical line equation look? I know that an equation for a vertical line always looks like this. X equals blank. I'm thinking to myself, I have a point. There's my x. There's my y. What is x equal to? Well, ding, 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 ding. There it is. X equals 2. That's all that we need to do for these kinds of problems. All right, next, we're on to absolute value. We know that if the absolute value, or the x is by itself, in the absolute value, we're looking at a vertical translation. And if the entire part of the equation is in the absolute value marks, we're looking at a horizontal translation. And so we set up our graph, and I know that when I'm looking at, redo that, I know that when I'm looking at y equals the absolute value of x plus 3, that plus 3 really gives me the y-intercept. So I'm going to start by plotting a point at 0, 3, and up 1 over 1 to the right, and up 1 over 1 to the left, and I'm ready to connect those points, and there's the equation, or there's the graph for y equals the absolute value of x plus 3. For the equation, y equals the absolute value of x plus 3, where the entire part of the equation is an absolute value. I know that's going to move in the opposite direction, so I'm going to start with my x-intercept at -3, 0, because we're moving in the opposite direction. And from there, I know to plot my points, up 1 over 1 to the right, and up 1 over 1 to the left. If I had an equation that said y equals the absolute value of x minus 3, such as this, we know that this would move us not to the left, but it would move us to the right. All right, finally today, we've got a couple of just more horizontal and vertical line practice types of questions. First of all, I'm looking at 2 points here, and I noticed something. I noticed that in both situations, the y value is -3. That should tell me something. It should tell me that something's interesting about the equation that I'm going to write here. But if you're not picking up on that, we could also find the slope of this line. And when I find the slope, I see that the change in y is 0, and the change in x is -2, which gives me a slope of 0. We know that a line with a slope of 0 is going to be horizontal and is going to be a y equals blank kind of equation. I could go through and plug in my points and do an equation in point slope form, or I could think to myself, well, there's an x, there's a y, there's an x, there's a y. What does y equal? Y equals -3. If you plugged in your point and slope, you would get the same exact answer. you would have y plus 3 is equal to 0 times the quantity of x minus 3. I'm using the first point. Y plus 3 equals, that 0 cancels everything out. Subtract 3 from both sides, and look at that. You're left with y equals negative 3. The easier way, I think, of doing this is just thinking about what are your point values. All right, here's another example. If I go to find the slope of these 2 points, I see that I have a change in y of 4 and a change in x of 0. And remember the day that we plugged into our calculators, 4 divided by 0 gave us an error message? What this is telling us is that the slope is undefined. I know what this means is that this is going to be a vertical line. I also know it's not a function because you can see domain values here that are repeating. I know a vertical line has an equation that looks like this. X equals something. And I think to myself, well, there's an x, there's a y, there's an x, and there's a y. What is x equal to? X equals negative 2. All right, 2 more problems. Same exact type of situation. Write an equation for a line parallel to y equals negative 2. Parallel, and it's horizontal. I know that a horizontal line is going to look like this. Y equals something. What is y equal? There's x. There's y. What is y equal? Hopefully you're thinking, 4, Mrs. Mall. Y equals 4. All right, same kind of problem. I know that y equals 2 is horizontal, but I'm looking for a line that's perpendicular. So I need to write an equation for a vertical line. I know that the equation for a vertical line is x equals something. I look back to my points. There's an x, there's a y. What is x equal to? X equals 2. All right, that's all I have for you guys today. We will continue reviewing on Monday, so if you have questions or anything here was confusing, go back, pause, rewatch, whatever you need to do. Come with questions on Monday for our last day of review, and behave yourselves today. Okay, have a great weekend. Bye, guys.